Now that you have a plan, know your location, and found the materials you're going to need to create the base that your oven will rest on. The base will support the oven from moisture both below and above. It needs to support the weight of the finished oven, which can be several hundred pounds, and be solid and sturdy so it doesn't shift. And lastly, it needs to raise the oven floor to your preferred height. It can be at any level that you desire. I prefer my oven to be at my waist so I don't have to bend over while cooking. It is also more comfortable for the arms and shoulders to be reaching and lifting at this height. As you can see in some pictures, the base can be made out of many different materials as long as you meet the 3 requirements. You can find other ideas online or in the book previously mentioned in part 1. Be creative and have the base suit your final design looks. With the base completed, it's time to make the oven floor. This will start with a round base, the final diameter of your completed oven, which will be about 14 inches or so larger than the interior of your oven. The base should be about 2 to 3 inches thick of an adobe mix, which I'll discuss with you in a few minutes. There will be a ring on top that's about 3 inches wide, just barely taller than the width of your glass bottles that you gathered. Arrange your bottles inside this ring as best you can, leaving about 1/4 of an inch between the bottles. Now you're going to take some sawdust. You can get some from the hardware store, wood shop, or a mill for free. Or you can even use finely chopped straw and mix it with a clay slip. A slip is clay that has been soaked in water and becomes a thick soup. The slip-covered sawdust should be a firm dough that can hold its shape. You'll stuff this dough in between the bottles and compact it very well. You will want to fill the entire ring with this mixture, and the bottles should be just visible. After you have it nice and full, you're going to spread another 1/2 inch layer of adobe on top, enclosing it. Now you might be wondering why the glass bottles and why enclose it. Basically, the bottles act as air pockets that will hold the heat longer and permeate into the surrounding adobe. It's fully enclosed so the oven base and the outside does not steal the oven and reduce the efficiency of your oven. Fully enclosed, it's time to lay out your oven floor of firebooks and visually see the layout. Spend some time maneuvering and see what works best. Your bricks will be uneven if left like this, and it will be difficult to make a level surface, so spread a thin layer of sand to even the surface, and then carefully place each brick. It's similar to laying a patio. You're going to place each brick right up next to the other, and don't wiggle them at all. Don't move them, just place them and move on. Slight cracks will get bigger over time, and make sure each brick is as close to level as possible with the others. When all of your bricks are placed, you're going to tamp each brick with your mallet and check with a level. It's more important to have a smooth surface than be perfectly level. It is, after all, just an oven. The oven is starting to come along, and it's time to get ready to play with some sand. If you've ever built a sandcastle, this will be similar, except we're making a dome. You will need a lot of sand for this, and I mean like 30 gallons or more, depending on the size of your oven. You can get sand from everywhere, even your kids' sandbox. Slowly pile up your sand to create a larger and larger dome. Be stingy with the water as you go. Too much and the bottom of your dome will become saturated, like ours. Once you get to the desired height and shape, please remember it's a nice rounded curve. Think of an upside down U with a slight flare at the base. Now, you're going to cover it with paper. We took paper from our recycling box. Dip the paper in water, spread it out completely, covering the sand dome in multiple layers. If you're going to be adding a chimney or an extended doorway, now would be the time to create that the same way you built the dome. We used bricks as a filler and piled the sand in the shape we wanted, and found a large cardboard paper roll to use as a chimney mold. This will be a good time to take a lunch break. Now that you're well rested and fed, it's time to start mixing your adobe. I hope you have everything and everyone that will be helping you, because you're going to be busy mixing a lot of adobe. And I'm not understating it when I say a lot. A good ratio for adobe is going to be 1 part clay and 3 parts sand. You'll want to make several tests of various ratios to see what works best. The book I mentioned in part 1 goes into great detail on the hows and whys of this ratio, but I can sum it all up to be that too much clay will cause cracking, and too much sand will reduce the stability, and you might get a crumbly oven. No one wants sand in their pizza. You're going to start with your dry materials, spread it out on a tarp, put on some good music, take off your shoes, grab a partner, and start dancing. Jump, jive, two-step, swing, tango. My ultimate favorite? The twist. It doesn't matter the dance or movements as long as those feet are moving. Well, I guess you might not want to break dance or do the worm, but, it's your preference. You'll be dancing for quite a bit. Seriously, you'll burn some calories and even smooth off the calluses of your feet if you go barefoot. Once it's all mixed well together, slowly add water to it and dance some more. The drop test is the best for finding the right consistency of water to your mix. You're going to make an earth ball. It's a snowball, but dirt. Pack it tight. Drop it from about waist height onto a hard surface. If it falls apart, there's either not enough water or not enough clay. If it flattens out like a pancake, there's too much water. And if it blobs just a bit but holds together and keeps its shape, it has just the right amount of moisture. Now you'll want to start making a lot of large earth balls. With your dozens of large adobe earth balls, you're going to make the first layer of your oven. The thermal layer should be about 3 to 4 inches thick. Before you place a ball, shape it into an oblong shape, and then place it firmly down about 3 to 4 knuckles thick. Use your other hand to support the outside so it stays upright. It needs to be up against your sand dome, but not pushed into it or it'll distort the interior shape. Each ball will be squished up next to the previous one. Lay each row one at a time before moving on to the next row. It's just like laying bricks. Don't let your seams light up. If you don't blend your row, you will start to see that each one is slightly indented like a beehive. Once you start reaching the top, you will no longer be pressing directly down. You need to press into the previous layer. You can see in the picture the correct hand position for this. This will keep your layer solid and compacted even towards the top and not alter your interior dome. Once solid, you'll smooth the outside. I rocked a flat board back and forth to ensure everything was well and evenly compacted and put together, and smoothly shaped. The first layer is complete and needs to dry a bit. This can take a few minutes or hours, a day or longer, depending on the temperature and humidity. Take a break and check on it occasionally. If you didn't create a door when you were building your dome, now would be the time to cut it out. It's like carving a pumpkin for Halloween. It's kind of fun. When it's ready, you'll start scooping out all that sand from the inside. You want to go slowly here as you remove the sand. Pay attention to your oven. If it looks unstable, stop and wait longer for it to dry more. As you get closer to the outside edges, you'll want to again pay attention and start using your hands. There was a reason for that paper layer, and here it is. Once you get to the point where the sand turns to oven, you'll feel the paper. You can either remove the paper or leave it. It'll burn out later when you light a fire anyways. We chose to pull out as much as possible and try to smooth some of the interior. It's not easy because you can't get in there to see what you're doing and you have to use your hands. Also, it's been drying and not as pliable as it once was. With the inside all scooped out, you can start cooking in your oven after it has dried a little bit more. If you want to have your oven be more efficient and retain heat longer, you can make an insulation layer of cob. You can also try your oven a few times to see if you want the insulation layer or go right on ahead and add one. To make the insulation layer, start mixing some more clay slip. Except this time it will not just be clay and water. You'll want to have equal parts clay and sand, and the slip will be thicker. Think of like a chowder consistency. Chop your straw up really well so you have 3 to 5 inch pieces. You can use garden shears for this, a leaf mulcher if you have one, or a weed whacker in a bucket. After your straw is chopped, add it bit by bit to the slip. Your final mix will be straw that is coated in slip and can hold together without dropping or slumping. Once you start applying this layer, it goes up really quickly. There's no need to worry about tight compaction. You want small air pockets in this layer for insulation. It will be about 4 inches thick or more if you want longer heat retention. It'll look like an oven now, and you should start thinking about how you want to finish the oven at this point. If you want to create shape to your oven, you'll want a sculpture layer, but this is optional. You can make your oven very unique at this point and do whatever your heart desires. There are lots of beautiful sculptured ovens out there, and you can get ideas on what to do on the internet. This layer is made using cob, just like the insulation layer, but it'll be thicker and the straw chopped finer. You can get a lot of details on mixing cob in the book and online. Think of what you want it to look like. Experiment with cob. Remember to step back and look at your work from different angles and distances. You can add other features into your oven at this point as well, including benches or a prep area. When you are satisfied with the look of your oven, it's time to add the final layer, known as the plaster layer. There are several different types of plasters that you can use. Each has its own benefits and drawbacks. An earthen plaster will be more natural as it consists of the same materials that you've been using all along, but it's not weather resistant and will require maintenance and a cover. A lime plaster uses masonry lime or natural hydraulic lime mixed with sand in a ratio of 1:3. This plaster will create a water-resistant surface that's still breathable and can be colored very easily. Please, if you use this method, be very cautious. Lime is caustic and can be dangerous. The last plaster option is with a cement or masonry type plaster. Using cement creates a permanent waterproof layer, but it prevents the oven from breathing naturally and can trap moisture inside the previous layers. If you use this layer, make sure your oven is completely dry as much as possible. This is the plaster that was chosen for this oven. There were several factors in choosing this, mainly because it's exposed to the elements with no ability to build a cover. The Pacific Northwest gets over 40 inches of rain a year, and with the club membership changing regularly, it was better to have a lower maintenance option. Regardless, whichever plaster is chosen, it needs to be mixed according to the recipe and should be a thick paste, similar to mortar. The layer should be evenly spread over the entire structure and can range in thickness from a 1/16 of an inch to an inch or more. The thicker you get, the harder it will be to work with and the more failures might develop in the plaster later. You can add decoration to your plaster layer, just make sure that the layer is continuous and you do not create areas that water can seep through. Your oven's now complete and you can begin thinking about what kind of food to cook. In your earthen oven, the possibilities are practically limitless. After all, the pioneers cooked everything over a campfire or on a wood stove. Also, if you plan your menu really well, you can cook almost all of your food for the next few days. Once heated and you take the fire out, you can cook food based on the internal temperature of the oven, starting with loaves of bread, then roasted vegetables, pies and cookies, nuts and beans, roasted meats, dried fruits, and even your kindling for the next time. But before you take the fire out, you can start your menu an afternoon of cooking with a live fire and make pita bread, fire roasted vegetables, and everyone's favorite, pizza. I swear, once you've had a wood fire pizza, you will never be able to enjoy delivery or a frozen pizza ever again. The flavors are intensified and it will be the best pizza you've ever had. Of course, the other benefit is that you are making it yourself and can customize it however you want. Your imagination and taste buds are the limit here. Thank you for watching part 2. And for those of you that are interested in learning and getting your hands dirty, trying it yourself without the worry of not having experience, I encourage you to come out and help us with our oven build in May or June of 2017. You can find our website in the description below.